So guys, a fair coin is tossed and a fair five-sided spinner with sides AA, BBB is spun. How many outcomes are possible? Okay, so this has a choice of heads or tails, and you have only two outcomes, I'm afraid, because it's repeated outcomes. You can only get yeah, you can only get a head and an a head and a B, a tail and a and a tail and a B. So if all them are different, you'd be right, but they're not different. So there's only two different outcomes in the second one as well. You can only have A or B, so there's four different outcomes. Okay, so look at this. We have a head A, head A, head B, head B. Head B is more likely to happen, isn't it? Because there's three of them as opposed to two of them. Tail A, tail A, tail B, tail B, tail B. Now, Ryan, you're technically right. It's out of 10. Yeah? Because 2 here and 5 sectors here. But there's 10 results, but a lot of the results are repeated. So there's only 4 unique results. Is everybody alright with that? Now, find the probability. So the answer to the first question is 4. Find the probability that of a head and an A. Head and A, guys? How many of them is there? 2 out of? Which is 20%, or 1 in 5. Okay. B, a tail and a B. 3 out of 10, and what Keane said, that's 30%, or just 3 out of 10. You can also write that as 0.3, or for the first question, 0.2. It's not too bad, was it? Okay, let's try question 5. 2 unbiased four-sided spinners are labelled with numbers 1, 2, 3, 4. An experiment consists of spinning them together, and the score is calculated by subtracting the smaller number from the larger number. When the numbers are equal in score, the score is 0. So you understand, if I roll a 2 here and a 3 here, the answer is 3 minus 2. If I roll a 4 here and a 1 here, the answer is, which is 3. Everybody alright with that? You gotta fill out the table. So look at this table, okay? You score a 1 on the first one, a 1 on the second one. What happens? 1 take away 1, 0. 2 take away 1, 1. 3 take away 1, 4 take away 1, 3. Anybody notice a pattern yet? 2 take away 1, 1. 2 take away 2, 3 take away 2, 1. Ah. Look at it, there will be, look. 3, 2, 1, 0. 2, 1, 0. Back up again to 1. 1, 0, 1. Up to 2. 4 take away 2 is 2. 3 take away 1, 2. 4 take away 1, 3. There is a pattern, but it goes back up again. When it hits 0, it goes back up again. Okay? Here? Okay. Look at it, right? The first one is 2 take away 1, which is 1. The next one is 2 take away 2, which is 0. The next one after that is 2 take away 3, or sorry, 3 take away 2, you just did is 1. And 4 take away 2, do you get it? Okay, now, don't want to get rid of that. Now, now, calculate the probability of score of 0. How many different scores do we have? We have 16 different combinations, don't we? 4 and 4 here. Like, there's 16 different things that could happen, but there's repeated answers. The only answers we have are 0, 1, 2, 3, and that's it. There's only 4 different answers. But that can happen 16 different ways. Okay? So, calculate the probability of a 0. How many zeros do we have? 4 out of 16, which is a quarter. Number 1, 6 out of 16, which is 3 out of 8. A 2 or a 3. 1, 2, 3, 4, 5, 6. 6 out of 16, which is 3 out of 8. Everybody alright with this? Okay. This one here, slightly different. A fair dice is thrown. How many different outcomes in a fair dice? How many outcomes on this spinner? 4. Now there's 24 different things that could happen. What do we need to do with them then? Adding them together. Okay? 1 plus 1, 2, 3, 4, 5. 3, 4, 5, 6. You get it? I'm just adding it. 1 plus 2 is 3, 2 plus 2 is 4, 2 plus 3 is 5. So all I have to do is count up. And now, but technically speaking, if you circle any one of these outcomes, yeah, if I circle 8, where do you actually get the 8 from? You get it from 4 plus 4. Everybody get that? You can circle any outcome you want, and all you have to do is just like, for example, this 5. Where does that 5 come from? Comes from 2 added on to 3. Is that alright? So that's how you can do it if you don't really like patterns. Now, here's what we're asked for. Frequency. Frequency is how many times we get it. How many 5s do we have? Oh, so how many 2s do we have? 0. No 2s. Where? Oh, sorry, we do. Sorry. 1, 2. Sorry. How many 3s? 2. How many 4s? How many 5s? 6s. 7s. That's interesting. 8s. 9s. And 10s. There's sort of a pattern there, isn't there? The central ones are the most numerous, aren't they? Now, what is the probability that it's a 6? How many outcomes do we have in total again? 6 multiplied by 4? 24. There's 24 different things that could happen. How many ways did we get a 6? 4 divided by is 1/6. 8 or more. 8 or more, guys? 6. Okay. 6 out of 24, which is 1 and 4. Prime. What are prime numbers again? No. Any number that can only be made by multiplying itself by 1. 2 is a prime number, 3 is a prime number, 4 can be made by 2 multiplied by 2, doesn't count. 5 is a prime number, 7 is a prime number. No, 9 can be made by 3 by 3. But 11 is not there. So 2, 3, 5 and 7. So there's 1 plus 2 plus 4 plus 7. So it's 3, 7, 11. There's 11 different numbers that will do the trick for us. As in, there's 11 different ways we can make these prime numbers. It's 11 out of 24. Divisible by 5. Which two are divisible by 5? 5 and 10. Add them together. 4. Sorry. As in how many ways they can have them. Okay.